Hey students, this is lesson 3.8. In this lesson, we're going to learn how to find the union and intersections of sets. Go ahead and do this review. There's some really important vocab here you need to pay attention to. All right, union of sets. Suppose that in a box there is a brush, a marker, a pencil. In another box there are a calculator, marker, ribbon, and brush. What items are in either box or in both boxes? So, okay, one thing I'd like to point out here is that let's just call this the brush, the marker, and the pencil. Set A. So that's this one, box A. And then the other set, we'll call that B. That's this set. Call that B. And then the thing I'd like to point out is that if it's in either box, then that's a union. So A union B, something that's in either box, and I'll put that down here. A union B, and the U symbol stands for union. So to be in either box, that could be our brush, our marker, our pencil, and then I need to include everything that's in the other box that I don't already have. That would be a calculator and a ribbon. So that's A union B. And then if I do the intersection of both those, so A intersect B, that would be items that are in both boxes, okay? And the things that were in both boxes are the brush, and the marker. All right, go ahead, you try that. All right, we're going to look at intersection next. Intersection is the items that they both have in common. And from a Venn diagram, that would be this shaded area in here. So the stuff that's in both A and B at the same time. And another definition here, disjoint sets are sets that have no elements in common. The intersection is the empty set. And here's an example of that. Notice they have no region where both A and B are covered. So they have nothing in common. Those are called disjoint sets. And we say that the intersection of those two sets is the empty set. All right, so let's try a problem here. It says set X is whole numbers less than 15. So I'm just going to write those out so you can look at those, although there's a lot of them. So X equals, and I'm just going to do it in roster form here. Whole numbers less than 15. Whole numbers start at 0, so 0, 1, 2, and they keep going up to 15. So all of those. All right. And then Y is odd integers. So to do odd integers in roster notation, odd integers can be negative numbers. So I'm going to do -3, -1, 1, 3, and they continue. That's what the ... is. And then Z is a multiple of 4. Those are only multiples of 4. Can be both positive and negative. And so those would be numbers like -8, -4, multiples of 4, 4. Actually, 0 would be a multiple of 4, isn't it? It's a multiple of everything. 4, 8, and so on. Okay, so the first thing we're going to do here is the intersection. That's of x and z, so what they both have in common. And that would include 0. That would include 4, not negative 4. 4, 8, 12, because 12 is in this set. And also, and that's it, because the next multiple of 4 is 16. So x intersect z equals, and we'll put that in roster form, 0, 4, 8, and 12. All right, and then y intersect z is equal to, so everything that y and z have in common. And you'll notice that z is all even numbers, and y is all odd numbers. So this is disjoint, these two sets. And so the intersection is the empty set. Or you can write it this way, like that. But that's because the sets are disjoint. They have nothing in common. All right, I'm going to let you try that. All right, we're going to learn how to make Venn diagrams here. So 3 friends are learning new languages. Draw a Venn diagram to represent the union and intersection of these sets. Which language do all 3 friends have in common? So Matt has Spanish, German, and Italian. So Matt, we'll put Spanish, German, and an Italian there. And then Rob has a Spanish and a German. So Rob has Spanish also. So I'm going to move this Spanish so it's in both Matt and Rob. Rob also has German, so we'll move that up there. And then it says Jane has Russian, Chinese, and Spanish. So for Jane, we'll put Russian, Chinese, and Spanish is already in Rob, so we're going to put that in the middle right there. All right, and that is our Venn diagram. So this section right here is shared by all 3. So that's why it's contained in all. And then German is shared by Rob and Matt only. Italian is just Matt. And Jane has 2 languages that neither of the other 2 have. All right, you try that. All right, so we're going to use this Venn diagram to show numbers and to solve a problem here. It says of 125 students in 5th grade, some have music on Tuesday, some have art on Tuesday, some have both classes on Tuesday. 68 have music on Tuesday, 33 have both classes on Tuesday. So right away, I'm going to put the 33 in the middle because that represents the ones that they both have. And then I know that 68 have music on Tuesday, so, but out of those 68, 33 have both, and so I'm going to just subtract, and that gives me 35 here. And then I just have to figure out how many have art, and I'm going to use the total to figure that out. I'm going to take 125, the total, minus the 35 that have only music on Tuesday, and that gives me 90 that have art. Then I'm going to subtract the 33 that have both art and music, and that gives me 57 who have art. And then just as a check, I would want to add all 3 of these parts up, because that should represent the total 125 students. All right, I'm going to let you try that. All right, the last thing we're going to do is learn how to solve an inequality and write the solution as a subset, or as a union, or intersection of 2 sets. All right, so to solve this, remember we need to isolate the absolute value, which we already have, so we have that, and then we're going to be less than 5 units from 0, shouldn't have used that, be less than 5 units from 0, that means that 2x minus 1 is somewhere between a number line, somewhere between -5 and 5. All these numbers are less than 5 units from 0. So they have to be greater than -5 and at the same time less than 5. All right, to solve this one, I'm just going to add 1. 2x is greater than -4 divided by 2, and we get x is greater than -2. And over here, we'll add 1, and we get 2x is greater than 6 divided by 2, and we get x is less than 3. And we have an and means it needs to be both greater than -2 and at the same time less than 3. Well, that's an intersection, so we're going to write this as an intersection of two sets. And that's going to look like this. I'm going to use set builder notation. And so I'm going to say, for this first thing, all numbers such that they are greater than -2 intersect the set of all x's such that x is less than 3. And that's how we write it as an intersect. Now, if this was an or, then we would write it as a union. So, and is intersection, or is union. All right, you can try the problem. All right, that's it. Go ahead and do the lesson check, and I'll see you in class.